All right, I'm sure folks will keep filtering in, but to keep on time, let's get started. It's just hard to wrangle conversations. So it's my pleasure to introduce Steve Vavrus. And Steve is a senior scientist and assistant director of the UW-Madison Nelson Institute for the Center for Climatic Research. In 2023, Steve was named the new state climatologist and the director of the Wisconsin State Climatology Office. And he is an expert on global climate change, Arctic climate, Wisconsin climate, extreme weather. And if there's a year to talk about extreme weather, I think 2023 and even just the first month of 2024 is definitely demonstrating that this seems to be our new reality. So please welcome Steve to talk about farm resiliency and dealing with extreme weather.
Good morning, everyone, and thanks, Aaron, for that introduction. How's the audio back there? Is that coming through all right? Okay. So we're going to talk about extreme weather today because that's something I do know about, but you know about farm resiliency far better than I do. And so at the end, I really want to have some ways that we can kind of meet in the middle and discuss ways to make farms more resilient and dealing with our extreme weather that we've been seeing so much of lately. And as an example of that, I'm showing this graphic. This is one that's really hot off the press, showing the trend in billion-dollar weather disasters around the country. And this is a data set that NOAA puts together. It goes back to 1980. And every bar represents, in each year, the number of these billion-dollar weather disasters. And they're color-coded, so you can see what kind of weather, whether it's drought or a flood or a freeze or severe storms. But the big takeaway here is the upward trend, right? You don't need to be a meteorologist to see that. It's just unmistakable. In the last decade in particular, there's been this increase, and then really extreme last year, 28 of these events, the most ever. And if you get under the hood a little bit and look at the color coding, you see that it's the severe storms in green that account for most of the years, at least more than any other type of extreme weather event. And those are the kind that really can impact farmers because that's hail, it's high wind, it's flooded fields and whatnot, as well as other sectors, of course. But it's for this reason, the fact that we're seeing more extreme weather overall, it's getting more expensive, that was a motivation for the creation of something called the Rural Partnerships Institute at UW-Madison 1 year ago. We were able to get funding from USDA for a grant, and the mission is to support Wisconsin's rural communities. And of course, a big part of that is agriculture. So the RPI, as we call it, it has three components. One is the State Climatology Office, which is what I represent as its director. Another one is a statewide network of weather and soil monitoring stations called the WICCI. I'll talk more about that today. And the third pillar is a set of rural community research and outreach projects that are being handled. I don't have time to talk about that, but it too has a mission to improve rural communities in our state. And by the way, I understand that some of you, maybe many of you, are from a place other than Wisconsin, so I apologize. This is pretty Wisconsin-centric, but I think some of the messages carry over to a broader region. So the State Climatology Office has been around for a long time, since the 1950s, but we were on literally zero funding for about 20 until last year. And so we're now revitalizing the office with this grant. And our mission is pretty simple, and that is to offer climate services that help Wisconsinites use weather and climate information most effectively. Now, what do I mean by climate services? And the way I would define it is the three I's. So one is information. So the office provides users with reliable weather and climate information. And that seems obvious, right? You want it to be reliable data, but like everything on the internet, there's some that's reliable and some that isn't. And so we help steer people to what we think is the most credible information to help with their purposes. Another I is interpretation. So even if you find good, reliable weather and climate information, some of it's technical and it's hard to understand. Some of it is just difficult to apply to a particular problem or question you have. And so our office serves as a climate consultant. And the final I is investigation, meaning research. So both basic and applied research, questions like, how is Wisconsin's climate changing and why? And then more pragmatic things like how can we create tools that'll help farmers answer some of their questions, whether it's an online tool or a development of an app. So it's very practical in that sense. So those are the climate services that our office provides. And by the way, I have some brand new bookmarks for the State Climatology Office, so you can get some swag here at the end. And I'm telling you, these are really hot off the press. I picked them up less than 24 hours ago. They're almost burning my hand. They're so hot off the press, so please come by for those afterwards. One of the products that we've been offering for the past year and will continue to is a summary of monthly weather climate conditions in our state, seasonal wrap-ups, annual wrap-up, whatever the time of year it is. And these are available both online on our website as well as through electronic distribution, and I'll describe that in a moment. But an example of that for the most recent summary for December, which is a really unusual month. It was a record warm December. This is the map of the temperature deviations from average. The red gives you a sense that it was really, really warm, especially up north. So the summary here, December, record warm month in Wisconsin, felt like a continuation of November, and then pointing out that this was the warmest December on record. The report also mentions this is the first time that Wisconsin has ever had a December when the statewide average was above freezing. December in Wisconsin, remarkable. And if you would like to get these, we encourage everybody to sign up for these, to get these electronically in your inbox, climatology.nelson.wisc.edu. And we've been really pleased by how much interest there's been in this, and it's just a super quick read. You could read it over a lunch hour and get up to date on the latest weather conditions in Wisconsin. Another product that is very new is one that we're partnering with others to create. This is called the Wisconsin Agriculture Climate Outlooks, or WACCO for its acronym. I didn't come up with that acronym, but that's just sort of how it evolved, easy to remember. And these are sets of slide decks that you can sign up for, and maybe 20, 25 slides, either weekly during the growing season or monthly during the winter. And this is a partner project with the Midwest Climate Hub, our UW Division of Extension here at Madison, and the NRCS. And so these outlooks, you can see the latest one here from late January, and then we had one late December and November. This will give you information about soil temperatures around the state from the WICCI stations that I'll talk about in a moment. It gives you information about the latest crop status from USDA, and then the outlooks the next week to 2 weeks to month to season to give you some guidance in your planting decisions. So crops and soils, extension.wisc.edu. And so this is something that we're kind of testing to see how popular it'll be in Wisconsin, but the Climate Hub has already tested this in other states like Iowa, and it's been pretty popular. So please consider signing up for those. WICCI. This is something that's, as I said, is a product of this new Rural Partnerships Institute. It's something that is not directly coming from our state climatology office, but it's one that we're closely partnering with. The leaders of this are at UW-Madison, Professor Chris Kacharik and project manager Chris Vagaski are the two who are leading this effort. And this is a really exciting new development because many states have these statewide weather and soil monitoring networks, but Wisconsin's has been piecemeal until now. But with this funding, the plan is to have at least one station in every Wisconsin county. So that would be 90 total, 72 counties, well, at least get that, and then some counties would have more than one. It provides real-time, and I'm 5 minutes, updates, real-time weather and soil information, soil moisture data, And the variables are not just the basics like temperature and precipitation, but you also get humidity, wind speed, solar energy, as well as soil conditions at 5 depths, all the way down to 1 meter. So that's temperature as well as soil moisture. And that is, a really helpful thing, because if you have a station in every county, it pretty much guarantees that you're going to have a reliable weather and soil data close to your spot, your farm, your home. Here's the current map of WISCO-Net stations. There's 20 up, and there's 70 more to go. You see they're not equally distributed around Wisconsin right now. Some of these were stations of opportunity. You see this big cluster here in Door County supporting the fruit growers, but over time these will fill out. There's going to be 25 deployed in this coming year, and the targets will be these big gaps that you see on the map. And so eventually in the next 2 or 3 years, we expect to have a full-fledged WISCO-Net network that would rival some that are already existing in other states, such as Oklahoma. And let me give you an example of WISCO-Net in action, just to give you a sense of one way that it could be useful. I don't think it's a news story that we had a drought last year, right? And it wasn't just Wisconsin. And one of the things that I found frustrating, being a state climatologist, is trying to get accurate assessments of drought conditions around the state. And one of the ways that WISCO-Net can really help with this is by providing real-time objective information using the same equipment all around the state. And as an example, I'll pick the Hancock station here in central Wisconsin. And I'm showing here the soil moisture reported from that station at 20 inches depth, starting at the beginning of April, when we had abundant soil moisture, through early October. And so this is the soil moisture measured here. The greens are the daily values. And you can see that for the first month or so, we were in good shape. And, you could pick up individual rainfall events and so on, but pretty stable, so no problems. But then look what happened in May. The bottom just dropped out. It got drier and drier and drier. And then we had the peak drought conditions in the middle of July. And then you can see we had a good rain here in August sometime, but then we dried out again in early September until finally we got more reliable rains. But this is great because now you can compare at a given moment what the soil moisture conditions are around Hancock versus around Door County versus way up north or the driftless area or what have you. So that's one useful purpose for it, for farming as well as assessments of drought. But the WISCO-Net is not the only game in town. There's a really well-developed citizen science rainfall collecting network called CocoRaws. How many of you have heard of CocoRaws? Anyone? Okay, so let me introduce it. And guess what? Got more swag for you. These are CocoRaws brochures, but this stands for Community Collaborative Rain, Hail, and Snow Network. That's a mouthful, but it's been around for about 20, 25 years. And what it is you sign up for CocoRaws and you get a rain gauge, standard issue rain gauge, so it's consistent with everybody else in the network. Put it up in your field, put it up in your backyard, and then each day, whenever 7 o'clock in the morning, for instance, you simply report how much rain or snow you got. And so it's really simple. You just, get on your phone or go online and enter that data. But it's very useful for, say, the National Weather Service and others to get these fine-scale measurements of precipitation. So even with radar, we can miss some things. And so especially in summer, when we get these small-scale rainstorms, it's very helpful to have that data. And you can see this example here. These are the dots that for a given day last October of CocoRaws reporting stations. So there's a lot in Wisconsin, but there are some places that don't have many, some counties that have only one or no stations. So we encourage people, especially those of you who have an interest in weather and have a vested interest, if you're in farming, to sign up for CocoRaws and provide that information. And it's useful for the Weather Service, it's useful for the State Climatology Office, as well as the Drought Monitor, which I'll talk about later. So with that background, I now want to talk about trends that we've seen in our weather and climate in Wisconsin. And the two key words here to describe the trends are warmer and wetter. And that warmer and wetter applies in very recent times, but also if we go back way in time, back to the 19th century, showing here statewide records beginning in the 1890s. That's about when accurate statewide records began in our state and many others. And showing first the annual average temperature by decade. Each bar represents a decade from the 1890s up to the 20-teens. And you can see a lot of variation from decade to decade. Notice, for example, the 1930s Dust Bowl was a warm decade, but even that is not as warm as we've seen in the state in the past 2 decades. So those have been the 2 warmest decades on record in Wisconsin. And when we look at the comparable trends in precipitation, we see an even bigger recent change. That huge spike here at the end is the 20-teens, higher than any other decade on record by far, and compared, say, to the really dry 1930s, but even all the other decades. And for good measure, the 20-teens ended with 2019 being the very wettest year on record in Wisconsin. And although this annual total on the graph only tells you how much fell, accumulated over a year, a lot of this came in really heavy doses. And probably won't be a surprise to many of you, we had a lot of super heavy rainfall events during the 20-teens, lots of flooding throughout Wisconsin. What I'm showing here are the number of so-called 100-year rainfalls. This is a rainfall amount that you would expect to happen only once per century on average, but instead Wisconsin had 21 in different parts of the state. So these are daily totals that I'm showing on the map here. And so the dots represent where it happened, and then the numbers represent how many inches fell on that day. And some of these are really huge. In Monroe County, 10.5 inches in one day. Is anybody from around Monroe County here? That was in 2018. And then a really damaging one right here in Dane County, basically a foot of rain fell in a day in August of 2018, and that caused all kinds of problems, not only for agriculture, but city stormwater problems and infrastructure and so on. So these are, exceptional, but yet the trend has been to see more of these heavy rainfall events as the warming atmosphere holds more moisture. Now, what I've shown thus far are either point measurements from the state or statewide averages, but we can break down these trends in weather for temperature and precipitation by county. If we go back not quite as far as the 1890s, but use, say, the middle 20th century as our starting point, and what we see, again, is warmer and wetter almost everywhere. On the left is the annual temperature trend going back to 1950. The warm colors, like yellow, represent a warming climate. You see most of these counties as bright yellow, 3 degrees warming since 1950. But you also see that everywhere, every county has warmed some. So the least amount is 2 degrees, the most is about 4 degrees. So fairly uniform, and these asterisks mean that the trend is statistically significant, meaning it's not just likely to be due to some random fluctuation in the weather. It really does represent a true longer-term trend. And every county in the state has a statistically significant increase in temperature since that time. If we look at precipitation, we see also generally a pattern in the same direction, that being wetter, but especially in the southern half of Wisconsin. You see that some of these are pretty large, about a 20% increase since 1950, but it does depend where you are. If you're in the far northern part of Wisconsin, the trends have either been really minimal or in Florence County up here, actually slightly drier. But for the most part, we can definitely say Wisconsin has been getting warmer and wetter, warmer everywhere and wetter in most places.
Have you been able to isolate like those extreme weather events versus like actual normal rainfall? Because if you are, I'm assuming it would be drier in most counties versus, I mean, not that those extreme weather events aren't extremely important to the weather, but is there any research or any data on that? to see how if I ignore those extreme weather events, because most of it's eroding off, or being able to penetrate, how much water I'm actually able to use.
Yeah, that's a good question. I haven't broken it down. I'm not sure if anyone has, but I think that's a great idea to do it, to just selectively say if you didn't have this one to affect the total. I'm guessing it's not going to change it too much because these are annuals, and so even if you get a 3-inch rainfall in a day, that's only about 10% of annual. But it's a great idea, and certainly seasonal. I think it could have a big effect. So good suggestion. But if we do break things down by season, this is the warming trend by season, again since 1950, winter, spring, summer, and fall. And remarkably, every county in Wisconsin in every season has been warming. You don't have to look hard at this graphic to see that winter has been the season that's warmed the most, especially in the central and northern part of the state, but really everywhere. It's all been significant upward trend. Spring and fall look a lot like each other and a lot like the annual trend I showed, whereas summer, the warming has been more modest. It's been typically about 1 degree or 2 degrees, so still upward, but not nearly as dramatic as winter. And so this winter, which is incredibly warm, especially in December, is really kind of an exclamation point on this longer-term warming trend that we see in winter. It's been the most pronounced season for warming. This year it really is extraordinary, or this winter season we're going through is extraordinary for warmth, but it's not completely out of the blue either, as you see from this ongoing trend. And winter is especially important for affecting plant hardiness. The USDA produces these plant hardiness zones that are really popular with growers, and the old zone, the maps were made in 2012, and just toward the end of last year, the USDA created these updated plant hardiness zones. So one of the things to note here, and I know it's a little bit blurry probably in the back to pick up these numbers, but all of these are based on the average coldest temperature during the winter season. And so the coldest zone here in the old maps was -30 to -35 degrees. So that would be, you know, on average, that's how cold it typically gets during a given year. And that was only true in far northern Wisconsin, away from the lakes. And one of the big changes here, noticeable changes, is that coldest zone disappeared. You no longer see that -30 to -35 zone. It's been replaced by a -25 to -30. So it doesn't seem like a big change, but still, it's representative of this warming climate. The other thing to notice is that way in the southeast, right along Lake Michigan, that's turned green. So that means a new zone emerged in Wisconsin that hadn't been there before. Notice here, it went from like kind of aqua-colored to green. And in that green zone, it means that on average, the coldest temperature in the winter is a pretty reasonable -5 to -10 Fahrenheit. I mean, that's cold, but it's not ridiculous. And so that's something, too, that's indicative of the warming climate. It's also, importantly, relevant or indicative of being right next to warm Lake Michigan. So the lake waters tend to be warmer than the land during winter, and so they get an extra boost. But the combination of proximity to the lake and the warming winter climate combined for this change in plant hardiness zone. Now, one of the things that is curious about the warming climate is in the behavior of some of the extremes. So I talked about the extreme rainfall. For sure, we're seeing more of these heavy rainfall events. But surprisingly, despite the fact that even the summers are warming, we haven't seen an increase in Wisconsin in extremely hot days. And I'll show that here. If we pick some of the most reliable weather stations from around Wisconsin, these are what we call first order weather stations because they're located at airports, they have good quality control, long records, hourly data. They're from these 7 stations. And I'm going to pick the lowest 6, those being Eau Claire, Wausau, Green Bay, La Crosse, Madison, and Milwaukee. And if we look at their records for, say, 90-degree days or hotter, if you're in Wisconsin, that's a hot day. And we look at the trend in those hot days averaged across those 6 cities starting in 1950. What's strange is we don't see an upward trend. There's a lot of year-to-year variability. So for instance, 1988 was a dreadfully hot summer. There were lots of hot days. But other summers have very few of these 90-degree days. And when we look at that 70-year-long trend, it's flat, almost flat as could be. And so it's odd. Why is this happening? However, and the headline here is the changing nature of heat waves in Wisconsin. What we find is a shift toward more nighttime extreme heat. So these are nights when the temperature doesn't drop below 70 degrees. So these are the really sultry nights when it's hard to sleep if you don't have air conditioning. And those have definitely been getting more common. They were typically only about 3 per summer back in 1950. We're up to about 8 per summer now. And particularly that's a concern in urban areas if you have an urban heat island, but it's important everywhere. And you can't really escape it no matter what part of the state you're in. So probably this is a reflection of higher humidity over time. Warmer climates can hold more moisture. More moisture really traps heat at night, more so than affecting daytime temperatures. So I suspect that the increase that we're seeing in humidity around Wisconsin, and this trend holds true for the upper Midwest as well, is probably causing this increase in extreme nighttime heat, whereas more moisture in the day, boy, that can produce more haze, more clouds, more rain, all of which can put a damper on the extreme daytime temperatures. So that could be an explanation. So now if we look at the trend in rainfall or precipitation, what we find is that it's getting wetter in every season, just like it was in the annual, but especially in winter. Winter has been the season when we see this big 20% increase in precipitation. We see increases in the spring and fall as well, although it depends somewhat where you are. But summer is strange. Look at summer. If you're in northern Wisconsin, you've been getting drier in the summer. And if you're not far away in central Wisconsin, you've been getting definitely wetter, like 20% wetter. So it's really strange that we'd be seeing such different trends, opposing trends, over such a fairly small geographic region, but that's what the data say. And of course, summertime rainfall is spottier, so that might explain some of it, the differences. But compared to the other seasons, summer is kind of an oddball in terms of the rainfall patterns. But as I have pointed out, there's the averages and then there's the extremes. And one of the things that's important is to document extreme weather because there's a lot of anecdotal evidence that we're seeing more extremes, but sometimes the firm evidence is lacking. So the State Climatology Office has been putting together this new extreme weather index, and it's a combination, it's kind of a equally weighted measure of precipitation extremes and temperature extremes. And I don't have time to go into the details, but I'm happy to talk to people about it afterwards. But going back to the records in the 1890s, this is showing that the value of the extreme weather index, so the higher the index, the more extreme weather in total that year. The highest of all was in 2016. Lots of year-to-year fluctuation, but the long-term trend and the running average here in the solid line shows an increase of about a quarter. So a pretty substantial increase in extreme weather overall in Wisconsin, combined temperature and precipitation, and the peak is in the 20 teens. That was the decade that we had the wettest Wisconsin as well as all those 100-year flood events. And then if we break down the index, that was a statewide average, break it down by region, what we see is a couple of things. So again, this is starting in 1895 to the present. Every climate division or crop division in the state, all 9, are showing an increase in this extreme weather index, but the largest increases of all are in southern Wisconsin, by far, the southern third, and south central Wisconsin, where we happen to be today, has the biggest increase of all, getting pretty close to 50%. That's a dramatic change over that amount of time, but if you're in the far northeast, it's been a lot more modest. So more extreme weather in Wisconsin everywhere, but the magnitude depends on where you're located. And as we heard in the introduction about extreme weather, last year we had a bunch of it, right? warmth was one. It was the 4th warmest year on record, so that's significant. But even that got overshadowed by the precipitation variations. So what I'm showing here, what I call precipitation ping pong, is the fact that we went from really wet to really dry, back and forth again throughout the year. This is showing for each month, January through December, the precipitation anomaly or the deviation from the long-term average statewide for precipitation. The green months are wetter than normal, and we had a lot of that. The first 4 months of the year, in fact, were the warmest start to a year on record in the state. And then we immediately dried out to the 4th driest May to August on record. May and June were terribly dry, and so then we plunged into drought. But then we had a wet October, over 50% above average, followed by the 8th driest November on record, and then ended on a wet note. So I just can't remember a year when we went back and forth this much in terms of precipitation. And that posed lots of challenges for farmers as well as other people in the state. But one of the big consequences, of course, of the dry spring and summer was the emergence of an extreme drought. The U.S. Drought Monitor puts these maps together each week to assess conditions in the state. At many points of the season, everywhere in Wisconsin was in some drought category, but by the end or by the middle of September was the peak, and you see some of these extreme drought in red, and even the highest category, exceptional drought, in the Southwest. This was the first time last year, the first time since the Drought Monitor began that any part of Wisconsin had ever maxed out on the drought magnitude, reaching this D4 exceptional drought category. So it was really a historic kind of drought. One of the ways that we would like to get help in assessing drought in Wisconsin and other states to help improve the accuracy of the Drought Monitor is if people would sign up and give their observations of conditions on their farm, around their yards, and so forth through CMOR. This stands for Condition Monitoring Observer Reports. And kind of like CocoRoss, but even less effort, you just need to go in about once a week and enter on your phone or online and just describe what conditions are like. How dry is it? Are pond levels dropping? Are plants wilting? Is the grass getting crunchy? That sort of thing. And the Drought Monitor authors look at that, and they really do look at it because our office contributes to some of the guidance. And they use that information to fine-tune those maps and determine what those drought categories should be. And those drought categories, in turn, determine which counties are eligible for federal relief during major droughts. So that was a big deal last summer, and the most accurate maps will come from having the most information. So please consider becoming a CMOR reporter next year. Another consequence, kind of a weird consequence of a warming climate, can be what we call false springs. And those are ones when a winter or spring are so warm that you get premature budding or blooming of plants that then get zapped when we flip back to a cold snap and they freeze. We saw a really big example of that in central Wisconsin last year. Wollersheim Winery, located northwest of here, lost almost their entire red grape crop from the false spring. Early April, the first half of April, super warm, 70s, even 80 degrees. And then the second half flipped to cold, and we had snowstorms. And that combination really was harmful for a lot of plants, including these vines at Wollersheim. And there was another spectacular example of a false spring back in 2012, which affected the whole upper Midwest and really hit the fruit growers. Strangely, this is something that probably will happen more often in a warming climate as we get these kind of winters more frequently, like we're having now, because, if this continues through February and into March, the plants are going to respond like it's spring, but there's no reason we can't have an April freeze, because we often do. And so if we have that 1-2 punch, that can be really damaging. And with that eye toward the future, where we're heading with future climate, that's more in the domain of another organization I want to introduce, the Wisconsin Initiative on Climate Change Impacts, or WICCI. This has been around for about 15 years. It's a combination, a partnership between the DNR of Wisconsin and the Nelson Institute for Environmental Studies here at UW-Madison. I'm one of the co-directors, along with Ann Kipper, in the DNR. And the WICCI's mission is very practical. We're trying to share and generate information to foster solutions to climate change in Wisconsin. So we sit at the interface between science advances and research, and climate adaptation, practitioners on the ground, like some of you, and we try to serve as the catalyst. And our work gets done by our 14 different working groups, shown here at the top, covering the themes of air, water, land, and people. Don't have time to go over every one of them, but of interest today, there's an agriculture working group as well as a climate working group. And we produced a pretty substantive assessment report a couple years ago describing Wisconsin's climate changes, the impacts and strategies and solutions. So I welcome you to look at that agriculture chapter in particular, because there are ag experts in that group, much more knowledgeable about that than I am, that might be of help. So one of the things WICCI produces is projections of future climate that are fine-tuned to different parts of the state. And where we're expecting in the future, by mid-century, the seasonal changes in winter, spring, summer, and autumn temperatures are shown here. And not surprisingly, just like the observed trends, we're expecting a warmer future. So no part of the state will likely escape, but just like we've seen in the observed trend, winter looks to be the season with the greatest amount of warming, and in large part because some of our snowpack is going to probably disappear. And when you lose snowpack in the winter, you can get an extra turbocharge of warming, which is exactly what we've seen in northwest Wisconsin right now. Up by Minneapolis and northwest Wisconsin, they got into the 50s last week, which is crazy for January. And had they had a thick snowpack like we had in southern Wisconsin, they wouldn't have gotten quite that warm. With that warming climate, we can expect more increases in hot weather. This is showing the change by the end of the century in 100-degree days. So mercifully, in the recent climate, where I'd say past, on average, we just don't have 100-degree days. Unusual summer, we might have one or two, but it's unusual. Whereas in the future, it's likely to become quite a bit more common. This is under a more high-end carbon emission scenario for the future, so it doesn't mean we'll get this warm, but this is one projection by late century, and 100-degree days would become fairly common, especially in southern Wisconsin, much less so if you're located by the cooling effect of the Great Lakes. But this is something, in terms of agriculture, for corn, for example, getting over about 86 degrees starts to have negative impacts. On the flip side, not surprisingly, these warming winters mean less bitter cold. This is the number of nights per year below zero. Fairly common, especially in northern Wisconsin, less so as you get to the southeast. But in the future, by the end of the century, we see many fewer nights below zero, and basically a disappearance of these bitterly cold nights in the southeast. So that would be have a big impacts, particularly for pest management, for example, and other things. So this is certainly the trend that we're expecting: more extreme heat, less extreme cold. Precipitation changes, a bit more nuanced, but wetter, certainly on average. Winter conditions by mid-century, everywhere in the state is expected to get somewhat wetter, typically about 15%. Spring is the other season that we expect to get wetter. Fall, yes, but not as big a change. Whereas summer, you see not much change showing up at all here, but I have a big red question mark by that. And the reason I do is because the climate models that go into these projections don't agree with each other in terms of even the sign of the summer rainfall change. Some predict we'll get wetter, some predict we'll get drier. And so when you take the model average, you end up getting this kind of washed out pattern that suggests not much change. But in reality, this is something that a research topic we've really got to figure out, because summer is our wettest season, and it's such a key one for agriculture. We can't just leave that red question mark on indefinitely. But where we are more confident is that when we do get rainfall in the summer or other seasons, it'll probably come down harder, again, because there's more moisture in a warmer atmosphere. This is showing a projection of the number of days with rainfall of at least 2 inches. In the past, the recent climate showing here, so it's more common in southern and western Wisconsin. And then in the future, that pattern of more in the south and west and less in the northeast continues, but you see the map just becomes bluer. And that just means that we're expecting to get more of these heavy rainfall events, and of course at least 2 inches. That could mean 3 inches or 4 inches. But at any rate, we're expecting to see the rainfall that comes in the future to come in heavier doses. And at the same time, we may be seeing more of these precipitation flip-flops or ping-pong like we saw in 2023. This is it takes a little explaining, but this map is showing the future changes in how frequently we transition between very wet to very dry, or very dry back to very wet. And what the maps are showing are for the future, for 3 different climate change scenarios, one where it's fairly modest, one's kind of moderate, and then a large climate change signal. They're showing these colors in orange and red mean that we're expecting to see more of these flip-flops between very wet, very dry. And so in terms of planning for that, it's important to know that, because you might end up getting the same total rainfall in a season or a year, but if it comes in this flip-flop pattern, that has implications for agriculture and other sectors. So keep this in mind. This is some research that's still being done, but it looks like this is the direction of change. And now I want to wind up here by just summarizing some of the trends we see in our weather and climate in Wisconsin, and many of these apply to the upper Midwest as well. One that we can say with confidence, I think, is warmer throughout the year. We're already going in that direction. Some of the possible impacts, changes in crop suitability, the plant hardiness zone map I showed, certainly a longer growing season is likely. Could be some different pest problems, pests that we haven't had to deal with in Wisconsin up to now. It's been too cold. More heavy rainfalls, that has implications for soil erosion and nutrient loss. As I ended with, more of these shifts between wet and dry weather, probably more swings between flood and drought like we saw in last year, and then maybe less predictable precipitation. Is this going to be one of those really wet months, or is it going to be one of those really dry months? And then at the end, I just put down some of the highlights for each season: winter, spring, summer, fall. Winter, probably wetter, less bitter cold, and more snowmelt events. More of this back and forth, but like we saw in southern Wisconsin this winter, where we get a good snowpack and then it dissipates, and then we wait a couple weeks till we get a new snowfall, it warms up, and we lose it. And that's different than the pattern that we saw years and years ago, when we would typically just build up the snowpack during the winter and then have a big flush of snow loss during the spring. But speaking of spring, that's another season we're fairly confident will become wetter, probably an earlier last freeze of the winter, and more of these false springs. And that has implications in terms of soggy soils to deal with in the fields, but earlier opportunities to plant at the same time if it doesn't happen to be too wet. And then this issue of premature budding and blooming of plants. In summer, although we've escaped it in Wisconsin so far, we're expecting more daytime heat to emerge and certainly more nighttime heat to continue, but uncertain rainfall changes in total. And that's frustrating, but we do think that when the rain falls, it'll come in more intense bursts. And that has implications for heat stress for crops and workers, as well as drier soils in between rainfalls and during dry years like we saw last summer. And then finally, in autumn, probably a later first frost, extending the growing season, probably wetter, although we're less confident in that. And that should extend the growing season and potentially allow double cropping potential in places that we wouldn't have been able to do years ago. So there's some trade-offs and just changes, some of which maybe not be necessarily better or worse in total, but they are changes, and they're things that we should be aware of and try to prepare for. And so I'm going to end there, but then make one final pitch. I've been doing a lot of pitching today, but this one was recommended to me by the Midwestern Regional Climate Center. They're conducting a survey of farmers to try to find out what type and what format of weather data is most useful for you. And this is just a simple 10-minute survey. Here's the QR code. It's funded by the United Soybean Board, and it really is just soliciting, like, you know, there's so much weather and climate information that could be provided, but they want to do it. Our office, State Climatology Office, wants to do it in a way that's most beneficial. So I encourage you to take that survey. It won't take much of your time, and by getting enough responses, we'll get a much better sense of how to package this weather information to be most useful for you all. So I will stop there and be happy to take questions and have some discussion. We got about 15 minutes left in the session, and as I said at the outset, I am not an agriculture expert, you are, and in terms of the title, Farm Resiliency in Extreme Weather, I want you to help me fill in the farm resiliency part. So that can spur our discussion. Happy to take comments as well as questions. So thanks for your time.
Can you talk a little bit more about polar vortices and like what happened a couple weeks ago? Why do we get those extreme releases of cold? And how are those going to be changing?
Yeah, get that question a lot, especially 2 weeks ago. So these so-called polar vortex events, which has really just become shorthand for cold waves, they aren't disappearing, right? I mean, despite our warm winter, this is a good example. It was super warm until that cold wave. It's been quite warm after it, but we had that burst of a week when winter finally woke up. And those largely are just, you know, random fluctuations in our jet stream. We happen to get the cold northerly flow off of Canada or even the Arctic Ocean coming down and affecting our weather. And we had another big event like that back in 2019 that was much bigger than what we just saw a couple weeks ago, and that made big news. And it was so cold during that cold wave. Where I live in Beloit, we had our all-time coldest temperature during that, minus 30. My furnace broke at the moment we hit minus 30, so I definitely remember that.
I did too.
Yeah, you did too. Yeah, so you'll never forget that. It's a horrible moment. But the state of Illinois hit its all-time coldest temperature during that cold wave too, something like minus 38. So, and we had another big cold wave in 2014. So we've had two major ones, and then a recent one just this month, or last month. And it just shows, first of all, that cold air is not going to disappear, even in a warming climate. But the other thing is that nature has a way of throwing curveballs at us. I mean, it's counterintuitive to think that in our warming climate, winter is the season that's warming the most, that you could possibly have an all-time coldest temperature anymore. And yeah, that's exactly what happened. So we just have to accept that those two things that seem like they're incompatible actually can happen. And it could be that as we get more accustomed to a warmer overall winter climate, we're going to be more surprised and have to sort of deal differently with these colder outbreaks when they come along, because people won't be expecting them anymore. And it'll be more akin to what we experienced this month where, hey, the winter's been so warm, how could we get so cold all of a sudden?
I think it makes it hard for agriculture. Just think about farm resilience. Think about pushing maybe some crops that we haven't been able to overwinter, that if their climate was more stably warm, might make it through. But especially with the variable snowfall and snow cover, you get 10 days of those temperatures, then there is still risk in terms of trying to decide, can we plant something that we couldn't plant? Is there truth to that being part of the destabilization of that cold air at the Arctic Circle with snow melt?
Yeah, so this is the question. So there's a hypothesis that, ironically, that a warming climate may favor more of these cold air outbreaks because it basically disrupts the jet stream and allows more of the cold air to come down. The jury's still out on that. I think there's some merit to it. But even so, even if we get more frequent disruptions of that jet stream to allow cold air to come down, the fact is that the Arctic is warming faster than anywhere in the world. So those cold Arctic air masses are getting less cold. So even if they make it down to Wisconsin, they probably aren't going to be as cold in the future as they were 20, 30, 100 years ago. So that has to be taken into account too, the frequency of the cold as well as the intensity.
environment kind and surprisingly peaceful.
About describing this, huh? Well,
Really, some of you might not be there in those 20, 70, 20, 90 years, but Ben and I probably will.
yeah, yeah.
Like, what are we going to do then? It seems, I don't have the words, but how do you, like, even personally cope with?
Yeah. Yeah, no, it's true. It's a heavy topic, and when I started this topic or this career in climate change, even the year 2000 seemed kind of far off, but 2100 just seemed like an eternity away. But a baby born this year, they'll just be 76. In 2100, lots and lots and lots of people live to be 76 and older. So that really makes it seem closer. And then, young people who aren't babies are going to make it that long too. So it really gives you the sense that the future is close, and on these maps. And but one thing to note is that, and I kind of glossed over it, is that was what's considered kind of the most pessimistic climate change scenario. In other words, the high carbon emission scenario. It's not the one that we're necessarily committed to, but it's one that we could easily go into if we're not careful. And it's sometimes called the business as usual scenario, because it's sort of like, unless we change, this is where we may be headed. But these climate model projections for the more optimistic carbon emission scenarios with more renewable energy and more regenerative agriculture, those are much more tolerable in terms of extreme heat changes or extreme rainfall. So it really is up to us. I mean, this is a human-made problem, and humans can fix it, but it's not easy, obviously, and it has a very long built-in sort of inertia to it. Even if we stopped emissions today, there's still some warming and climate change in the pipeline that we'll still see, but it's kind of like slowing down a fast-moving train. If you want to stop it and reverse it, the first thing you have to do is slow it down. Mm-hmm.
How your work can help to build new insurance programs for farmers? Because we feel we have a lot of different issues in Quebec. We have water, rain all the summer, and we look about the tools for the government to try to help is plan of the whole data, not ping-pong data,
Mm-hmm.
and how you can help for build new to explain. Sometimes for the politician make advocacy to explain this reality and to have help to be the resilient place will move now.
Mm-hmm. Yeah, and I don't know the political climate or the politicians' mindsets in Canada and Quebec as well as I know it here, but you can see that there's quite a bit of nuance here. Like 2023 here in Wisconsin, for example, the total precipitation was close to normal. But it was anything but normal every month. And so that is something that politicians need to know. It's not just the simple averages, but it's how it evolves and these in-between variability aspects that matter too. So thanks for bringing that up. Uh-huh.
The weather changes that you have, can you peg them to the carbon concentration of parts per million? Because I know in some activism that I do, we go with 350 as sort of the stable parts per million.
Mm-hmm.
And I think now we're close or reached 420.
Mm-hmm.
And I'm reading a book called Ministry for the Future, in that bad things happen at 460, and then the book has a good ending to it. They turn the tide and it starts decreasing,
Mm-hmm.
and they moderate a lot of the extremes. Does your weather stuff, your weather information, does it follow the parts per million closely, or
Yeah, so this issue, are there sort of thresholds or tipping points that, a certain carbon concentration, CO2 concentration, or even a global average temperature amount? So typically what people have said is when we get a global average temperature more than 1.5 degrees Celsius or close to 3 degrees Fahrenheit above the pre-industrial value, so say a couple hundred years ago, then the worst impacts of climate change start to be realized. And that certainly can be true for certain types of events, maybe flooding or heat waves, but I like to think more in terms of it being a continuum rather than having firm thresholds or even inflection points, because first of all, if we think in binary terms, are we going to stop climate change or aren't we? Well, we've lost the battle right there, because there's going to be climate change, right? The key is that we try to minimize the magnitude of it, and whether we're at 380, 420, 460 parts per million of CO2, we're going to deal with that climate change that corresponds to it. Clearly, the more CO2 we put in the atmosphere, the more of a warming impact, the more of a climate change signal we'll see. But precisely how that will evolve is still an open question. If you look at the historic climate record, the paleoclimate record from the geological, like ice cores, for example, you see examples of climate change sometimes being gradual and other times being very abrupt. So I think there are things like inflection points and tipping points in the system, but they're very hard to detect ahead of time. But it's definitely sobering to see, for instance, in Greenland, that suddenly the snowfall doubles within a decade and stays that way. If our precipitation doubled around Wisconsin, what would we do? I mean, it would be unimaginable. So sort of an in-between answer to your question. I definitely see that there can be these thresholds that we should be concerned about, but I think we should just be, accept across the board that there's going to be climate change as we inch our way toward higher CO2 and methane concentrations. Mm-hmm.
That first slide you showed about the extreme events cost on the country. Are there? I mean, I grew up in New York, and so during Hurricane Sandy, it cost New York City about $15 to $20 billion to recover from that.
Wow.
Of course, they said they were going to, put programs in place to prevent that, and then, 2 storms later, we're $40 billion a day again.
Mm-hmm.
And I'm wondering if you have any ability to be able to locate kind of like big cities or even like larger towns costs and subtract that, so you can kind of actually see the rural and the farm expense. Because especially for me, investors and own my land and own the operation, and trying to, obviously they've spent a lot of money already, and obviously having them double down on things, different practices and different, earth moving or, ability to be able to deal with those extreme events is something that obviously they're very interested in, but seeing, this rise in that projection might be able to kind of show them, and also banks and other things, or other lenders, really showing them data on why we need to do this now, or why we need to start focusing on this in, the near future rather than the far future. Is there any way or any, ability for you to be able to kind of locate those and pull those out, so, as farmers you kind of see and then educate people that we're trying to, get lending?
Yeah, that's a great point. So I think the data are out there. Finding them in the right place or format to be most useful is tricky. I mean, FEMA has this kind of information for disaster losses by county. Insurance companies have it too. You make a really good point that it needs to be separated between urban and rural, because, hurricane hits Miami and there's going to be, incalculable damage, but that's Miami. That doesn't necessarily apply to rural Florida. So I think there are ways to tease that out if you looked at FEMA maps. I've tried to do that a little bit, but it's kind of overwhelming because it's just all these rabbit holes of statistics and charts and Excel files, and pretty soon you're like, I'm going to stop. But it's a good project for people to pursue because, the dollar costs are critical. And I know insurance companies are very concerned about these trends. And in some places, in California and Florida in particular, it made news that they're no longer going to insure certain locations because it's just too risky. And we certainly don't want to get to that point.
I wrap up. One more question.
Okay, more?
I see the one slide you had up there talked about the growing zones changing.
Mm-hmm.
And I'm from Pennsylvania, and I'm thinking, okay, talking around other times here at the conference, they were talking about the zones have moved north, and I'm thinking, okay, how do I adapt to it? Do I need to start growing a longer season corn? Is this available, information available for Pennsylvania?
Yeah, absolutely. Yeah, the USDA has made these plant hardiness zones for the whole country. I just showed it for Wisconsin. But importantly, and something I just learned recently, is that those plant hardiness zones are a little bit of a misnomer because as far as I understand, they're based solely on the coldest temperature of the winter. Whereas you typically think intuitively like, oh, plant hardiness, that must have something to do with year-round temperatures, right? Or the length of the growing season or how hot it gets in the summer. My understanding is it's not. So maybe we need a more sophisticated tool than for a plant hardiness that takes into account the temperature in all seasons.
I think that first and last frost date too is correct. I don't, that the first and last frost date isn't taken into account.
I don't think it is. Yeah.
Agriculture and crop.
Right.
You have that for Wisconsin, and probably other states have those changes.
Yep. Exactly. So the growing season certainly lengthened in Wisconsin, as you would expect, but precisely how much, I couldn't give you a number on that. But the same is true for other states. You can get information like that for Pennsylvania or Iowa.
Well, let's thank Steve again.
Thank you.